Okay, so now the next one that we have, that is one-way ANOVA. Let's see the theoretical aspect first, and then we will be looking at the hands-on. Okay. So now we have discussed about the if the two variables are categorical, we go for chi-square. If two variables, one of them is quantitative, that is numerical, and the other one is categorical, we go for the t-test. Okay. And if we have just one variable and we want to compare it with the standard, we go for the one sample t-test. If we have two variables but they're not paired, we go for the independent sample t-test, that is male and female levels of depression and stuff like that. And if two variables are paired, we go for the paired sample t-test. Okay. What if the group number is more than two? That is, it's not male female, it's male female and another gender. Or sorry. And what if it's not? But if it's not the levels of education, we go for primary, secondary, tertiary level of education and the quantitative variable. Okay. So now I'll be telling you, showing you guys even one example. Okay. So if the categorical variable is not paired and it is more than two, we go for ANOVA. And it's what is the corresponding non-parametric test? That is the Kruskal-Wallis test. And okay, so what are the example? Is there a difference in the anxiety level, depression level among first year, second year, third year, fourth year, and final year medical students? Or is there a difference in the weights of first year, second year, third year, fourth year, and final year medical student? Is there a difference in work-life balance of doctors of different specialties? We go for the one-way ANOVA. Okay. So just let's apply it. This is the way to report it, and even you can search it on Google, okay, and you can always find how to report this specific test, okay. Okay, so let's test. I wanted to do between the weights and between the levels of fatigue. Like, is there a relation between weight and the fatigue level that we this one stiffness? Okay, I want to do between this and this. So there are three groups: low stiffness, extreme stiffness, and moderate stiffness. And this is the quantitative variable. I want to run a ANOVA on both of them. Okay, comparing them. So what I will do, I will go into analyze. I will go for compare means, one sample ANOVA. Okay, in the dependent, I would write what is the dependent variable, that is my weight. Although it is an independent one, but we have to make sure that the dependent one is a continuous variable. Okay. Otherwise, we cannot run the ANOVA. And the fatigue levels are independent. Contrast. In contrast, we will not change anything. In post hoc, we will apply Tukey's test right now, and I will explain it to you what is it about. Okay. Okay, so we are now applying it. Okay. So in the ANOVA test, we have to just see some of the stuff that is important. It's saying that the ANOVA between the groups, it's not significant. Okay. So if it was significant, we would have went on to identify what is the significance, what is the level of significance that we have. Okay. And but if it's showing as not significant, we can simply write that there is no statistical difference between the different groups of fatigue regarding weight. Okay. We would have said that there is no significant effect and there was no significant difference between the levels of fatigue. We can reject the null hypothesis that there is we will have to accept the null hypothesis that there is no difference. Okay, we suppose that the t-test come out to be, ANOVA comes out to be less than 0.05. Then we will have to go to the post hoc test. This is the post hoc test. We'll go here. And what we will see here, we will see that what is the comparison, and we will see the comparison between the different levels. Okay, that is what is the relation between low stiffness and moderate stiffness? Is it significant? No, it's not significant. And between extreme level of stiffness, it's significant or not significant? So it's not significant. If this result comes out to be significant, then we run the post hoc test to see that which is the level that is significant, that is causing the whole value to be significant. Okay. Suppose if it was significant, then one of this variable would have been significant. Okay, maybe the extreme level of stiffness would and the moderate level of stiffness would have been found significant. So we would have reported that there is a statistical difference in the weight of people who are experiencing extreme level of stiffness and those who are experiencing moderate level of stiffness. Okay, so ANOVA is like that. Let me run another test again. Maybe it comes out to be uh, okay. So I'm doing going for weight and year of study. One way ANOVA. Weight after exercise. Weight before exercise. And okay, let me check. This is a year, and I just insert variable and I paste it here, and I name it as year. Okay. I don't know why was it not showing in my data set. Okay, okay, let me change the name. Happy now. Okay. So now again I analyze, compare means, one way ANOVA. This is numerical, why is it not showing? Okay, so let's do it again. Okay, let me pause the recording for now. Okay. It was just having a problem. I reset it and it is now showing. Okay. So now we have fatigue we have added here, and year we are going to add here. Okay. And I estimate the effect size, and post hoc I have added the two case test. Okay. Mm, yeah. And I press OK. So once again, it has shown me those things that is between the groups, because the data is almost saying it's saying that there is no significance, and again the total is not significant. Okay, so now we are doing between weight and year of study. I have made another variable of year of study. Okay, and in the post hoc we will apply the two case test, and okay, and estimate the effect size for the overall tests. Okay, so now here we have it is also showing as not significant, but we will still move down here to the post hoc tests. I guess it will not show the post hoc test because it is not significant. Okay. So, but if it comes out to be significant, you run the post hoc test, and you can share the even any of the set with me when it comes out to be significant. I will explain to you in that one also. But the post hoc test is to see that if there is a significant relation between that variable and the other one. Okay. So, what is making the ANOVA as significant? We will run the post hoc test. And okay, last thing we have to see is this one. The type of the test, the parametric test, independent sample t-test, its corresponding was a man-Whitney's, pair t-test was Volkos signed rank test, one-way ANOVA, it was called Wellerstedt, and for the chi-square, it was the Spearman correlation. Okay. You won't be using these very frequently or very often. You will be using more of these parametric test. Okay. In the next one, we'll be discussing about the odds ratio.